the wrong page. Okay, you try this one. Change it to radians first, or to degrees, sorry, first. See if you can figure out what that answer is, that ratio. Oh, yeah. So you just always do that in practice. Oh, right. Yeah, that one, but this angle is absolutely right. Yeah, your reference angle is always drawn to the x-axis. So you got 330 here. That's 330. Now remember, a whole circle is 360. Now draw, start here and draw around 330, a whole circle, 360. And then draw your reference triangle. Good, that's right. Yep. This crap, so you don't have to do that. Okay, I'm pretty sure everybody got the 330, which is good. We multiply it by 180 over pi. Pi's cancel. 6 goes into 180 30 times. 11 times 30 is 330 degrees. So we're really finding the secant of 330. Then we draw that in standard position, which means the positive x-axis is the first side, the initial side, and the terminal side should end in the fourth quadrant here. So that's 330 degrees. Our reference angle is what's left over here, which to make that a whole circle, I need 30 more degrees. And it's always to the x-axis. It's the acute angle drawn to the x-axis. So across from 30 is 1. It's negative 1 since it's going down. Across from the 60 is the square root of 3, and it's positive since I'm going to the right. And the hypotenuse is 2. So now secant is the reciprocal of what? Not tangent, because cotangent and tangent. The cosine, yes. So if cosine is adjacent over hypotenuse, then secant would be what? Hypotenuse over adjacent. So the hypotenuse is 2. And which side is the adjacent? Square root of 3. Cosecant of 4 pi over 2. That will reduce in and of itself. That's cosecant of 2 pi, right? Because 4 divided by 2 is 2 pi. Plus tangent of 5 pi over 4. So what I'm going to do, kind of draw a line here so I can. So how much is 2 pi? Remember how many degrees that was? 360, yeah. If you didn't know, you could take 2 pi times 180 over pi, and you'd get 360. So here's the deal. 360 is a whole circle. So it's going to end right here. And people are like, and I don't blame them, because how do you have a triangle? You don't. You don't have a triangle if it's just, you know, here, and then it ends here. It's just a line. So when that happens, when it lands on one of the axes, that's when you revert to the unit circle, which is why I told you, oh, this is so important. So on a unit circle, what's that point? To the right. Think about it. It's unit. You're going to the right 1. Yeah. And then you don't go up or down at all. So it's 1, 0. All right. Now, we don't have opposite, hypotenuse, all that stuff. So that's when I also said, oh, I'm going to go back up and kind of go over this stuff up here. Circular angle definition. For sine, if you go back up here, we have x is going this way, and y is going this way. Here's my angle. So I have opposite over opposite. This is adjacent. And how much is the radius if it's a unit circle? A unit circle. It's touching the circle right here. On any unit circle, what's the radius? Unit. Ooh. This is just a different x and y. So if r is 1, then the opposite is y over the radius, which if it's a unit circle, is 1. So sine is just y in a unit circle. For cosine, it's adjacent over hypotenuse. So that's x over 1. Tangent is opposite over adjacent. So that's y over x. How do I find cosecant? Flip it. Flip what? The sine. So it's 1 over y. Secant. 1 over x. Cotangent. Now this is only for a unit circle. So that comes in handy. So for this unit circle, I'm talking about cosecant. Cosecant is 1 over y. So it should just be 1 over 0. So it's going to be undefined. We'll work on this a little bit more. Like I said, you're not going to have to do the homework that goes with this, because we're going to do this for a little bit. I'm going to skip that homework.